Problem number 26. A current of 4 amp passes through a 10 ohm resistor. So calculate the power developed by the resistor, and the second one is calculate the energy dissipated in 3 minutes. So we have to find the power and energy. So let us assume one 10 ohm resistor. So this is 10 ohm where the current of 4 amp is passed. So first we need to find power. Power is nothing but I square R. Here I is nothing but 4 and R is 10. So power is nothing but 160 watt. So once we get the power, we have to multiply this power into time to get the energy. That is energy W is equal to P into T. So we can take this T, they have given it as 3 minutes. So if we take it in seconds, it's 180 seconds. So if we multiply 160 into 180, that is 160 into 180, we get 28,800 joules or watt second. So 28,800 watt second is the energy dissipated in 3 minutes. So problem number 27. A heater is given a current of 10 amp from a 250 volt source for 15 hours. Determine the energy consumed by the heater in kilowatt hours. So in previous we have calculated in watt second. Now we have to calculate kilowatt hours. So they have given that a heater. So let us assume this as an heater which is connected to a voltage source of 250 volts, and the current to the heater is given as 10. So first we need to find power. Power is nothing but V into I, which is nothing but 2500 watt. So when we convert this into kilowatt, we get 2.5 kilowatt. So as we know, energy dissipated is power into time. So W is equal to power. That is, so we need in kilowatt, we got power in kilowatt, that is 2.5. Time is 15 hours, it's already in hours. So into 15, that is nothing but 37.50 kilowatt hour. Problem number 28. For the circuit shown in figure 1.36, that is this figure, determine the power developed by each resistor. So first, to find out the power developed by each resistor, we have to find I1 and I2. So for I1 and I2 we have a formula. So for I1 we have I1 is equal to I into R2 whole divided by R1 plus R2. So we know I is 12, R2 is 5, and the sum of R1 and R2 is 15. So this will become 1 by 3 and I1 will become 4 amps. Once we get I1, we can get I2 easily, that is 8 amps, because total is 12 amps. So once we get I1 and I2, we can easily find P1 and P2. So this is I square I1 square R1, that is 16 into 10 is equal to 160 watt. Same thing P2. I2 is 8 square and R2 is 5, that is 320 watt. So P1 is 160 watt, P2 is 320 watts. Problem number 29. two resistors connected in parallel across 100 volt DC supply take 10 amps from the line. The power dissipated in one resistor is 600 watt. What is the current drawn when they are connected in series across the same supply? So they have given the diagram is shown as what they have explained in the question. So two resistors are connected in parallel where I is of 100 volts, where it take 10 amps from the line. So I will be 10 amps. So in that, one of the power dissipated in one resistor is 600. So let us take R1. So here the power dissipated will be 600 watt. So if R1, the power dissipated in one R1 resistor is 600 watt, so we can find I1. How? Because we know P1 is equal to V into I1. So we have got, so same we can write I1 is equal to P1 by V. So we know power is 600 and voltage is 100. So we will get 6 amps. Once we get I1, I2 we can easily get by substituting in this formula, that is 10 minus 6. So I2 is 4 amps. So we got I1 and I2. Once we get I1 and I2, we can automatically find R1, that is V by I1, that is 16.66 ohms, and R2 is 25 ohms. So this we have got everything from the figure 1. So what they are asking is, what is the current drawn when these two resistors are connected in series? So if these R1 and R2 are connected in series, we have to add. So 16.66 plus 25 will be of 41.66 ohms. So we got the total resistance. So current formula is I is equal to V by R. We know V 100 by 41.66. Therefore I will be 2.4 amps. This is what they are asking.